Alright guys, we're going to start out with dealing with 1.1 for analyzing categorical data. So with this, you can see categorical variables starting out right here. This shows that we can report frequency in counts and relative frequency as a percentage.
Yeah.
And pie charts or bar graphs. So what we're looking at really is start out with pie charts and bar graphs. Everybody's probably got a pretty good understanding what those are and how they play out those.
Yep.
The big thing is we talk about now is two-way tables. Okay, now the structure right there is set up with your the 4 blocks there. We're talking about your A values and your total values over there. Okay, so now with that we're going to look at dealing with. So we're going to deal with marginal distribution, which is, as you see from the table there, you got B over C. And if you're looking for a joint distribution, that would deal with A over C. And conditional distribution, which is A over B. So with that, you're looking at the totals for C is the total overall for everything for marginal distribution and joint distribution. Your conditional distribution is dealing just with that condition they're asking for. And we'll go over that a little bit. You'll see that in just a second. The star there is talking about there's association between two variables if knowing the value of one affects the other. So if the value of A affects the value of B, then that means there's association, which kind of makes sense. If anything was a change in A, it's going to cause that B value to change as well as the C value, right? So that is where an association, okay? Going on in with this problem here, we've got students at a local high school were asked which gaming system they prefer, the PlayStation 3, Xbox 360, or neither. The graph shown at the right shows the results. Explain why the graph may be misleading. So why do you think it would be misleading? Well, looking at this, first off, big key thing to me is, where is it starting at? What is this value right here? 44.5. Well, I would want that to be at 0. Otherwise, it doesn't really show a true difference in these. So, does not start at 0. Does not. Start at 0. Okay? And so therefore the difference in the heights is exaggerated. So the height difference is exaggerated.
Hey Dad, my mom's making some cookies.
Okay, buddy, go. Oh, you too. All right, height difference is exaggerated. What else we got going on? Let's see. Also, too, we can't really tell what the neither is because it doesn't even show anything. It's just no height whatsoever. So, what if that was stopped right before the 44.5? Why did they start off right there? So, you definitely don't want to deal with anything that looks like that pictorial-wise, right? The pictographs should be avoided. Don't use these pictures because it's very misleading. This PS3 looks huge compared to this Xbox 360. And then it doesn't even start at 0, so it didn't even show you the true difference according to the heights they were going off of. Okay? So it's a big thing to take off of that. Just mainly the big thing is looking at 0. It's a very common question they like to ask. And they'll actually not really ask, but try and get you to figure out. Alright, this next part says an article in the Journal of the American Medical Association reports The results of a study designed to see if the herb St. John's wort is effective in treating moderately severe cases of depression. The study involved 338 patients, so that's our sample size, who were being treated for major depression. These subjects were randomly assigned to receive one of 3 treatments: St. John's wort, Zoloft, or placebo, okay, for an 8-week period. The 2-way table summarizes the data from the experiment. So, part A is asking what proportion of subjects in the study were randomly assigned to St. John's wort. Explain why this value makes sense. So, with this, first off, before we even do anything, when I see a 2-way table like this, they're going to ask questions about trying to get some type of percentage, some type of ratio set up there, okay? So we need to figure these out with these totals, okay? So on these, let's go ahead. I'm just going to draw a line right here, a line right here. Okay, and we're going to say the totals down here, okay? Because then we're going to say is our overall total right there. So let me get the calculator here and help us out with this a little bit faster. So let's move this down right here, get this a little bit easier. Okay. So we're gonna go with, so we got 27. I'm going to do the full response first, so I'm just going to go across this way first. So I'm going to do the full response. We got 27 plus 27 plus 37. So we should get 91. Okay. So we got 91. Then we got 16 plus 26 plus 13. That gives us 55. Alright, so we can write 55 over here. Sorry guys, my numbers aren't beautiful. Still getting used to this tablet here that we got. So, alright, so then we got, let's see. Then we got 70 plus 56 plus 66. So, 192. So, 192. Okay, so now it's a horrible 9 there. Oh, just gotta reset. That's horrible. It's bugging me. 192. Alright, so 192. Now, okay, so now let's go here. We got underneath there, we got 27 plus 16 plus 70, because now we added the rows, and now we're going to add the columns. So now this should give us 113 for John's wort.
Oh yeah.
Thanks, Maddie. Please go watch your movie.
I want to watch it.
Okay. Alright, so now we need to get the Zoloft column, so we'll do 27
There's a Lego here.
plus 26 plus 56. And that's 109. And then we need to add the last. So we got 37 plus 13 plus 66. That's 116. Alright, so now these two totals should add up to equal the same. So we're going to do that just to verify. So we got 91 plus 55 plus 192. So she got 338, and then we should have 113 plus 109 plus 116. So they both equal 338. So we know we got those right. Because this total should equal 238 and this total should equal 338, which makes sense. Hopefully that makes sense to you and understand that. So with this, now it's saying the proportion of St. John's wort. So we know that in here, if you look at this, St. John's wort, well, they got a full response, a partial response, and no response. So we don't just use one of these values because it's saying just says St. John's wort, who used it treatment-wise. So the treatment-wise, the treatment total for that is 113. Well, then, if that's 113, what do we need to put that over? Well, we want to put that over the total of everything. So, out of everything that was studied-wise, the Zoloft, placebo, and St. John's wort, we're simply taking 113 and dividing it by 338. Let's see what that gives us. So we should take 113 divided by 338. Oh, I need to put control first, sorry. So this should give us 0.334. Okay? Explain why this value makes sense. Well, let's see here. So there are 3 treatments, right? 1, 2, 3. And out of those, our total was 338. So these are all sitting just a little over 100. So that makes sense because it's just like a third of it was assigned, right? So with this, we could say there were 3 treatments. Those look a little bit better. There were 3 treatments. And so about a third should be assigned. So about 1/3 should be assigned. Otherwise, it's not a very fair study if they didn't at least make it somewhat close to being equal, right? For all the different treatments. So for part B here, it says find the distribution of change and depression for the subjects in the study using relative frequencies. So change and depression, that's the key thing right here, change and depression. Well, that's looking at these guys right here, right? Change and depression. So not the treatment in the columns, but the rows, right? So the rows for this, and it wants to find the distribution overall. So we're finding these distributions. We're simply taking our end total over our overall total. Okay, so the row total over the overall total for everything. Because like in our big ideas, that would be like our marginal distribution. So you will see problems where they ask, what is the marginal distribution for such and such? So if that's the case, if you're asked for marginal distribution, you're simply taking the marginal, your row totals over the overall total. So in this case, we've got, I'm just going to say the full response. Say that's 91 over 338. And then I'm going to say the partial response is 55 over 338. And then we'll say no response is going to equal 192 over 338. And with those, I already used calculations, so instead of pulling out the calculator to do these, this should give us 0.269. For the partial, this should give us 0.163. And then over here, we should get 0.568 for no response. Okay. So that would be our actual distribution of change in depression, okay, using relative frequencies. So relative frequencies for those, that gives us that setup right there. For the last part right here, for C, it says, what percent of subjects took Zoloft and showed a full response? So they took Zoloft, right? It took Zoloft and showed a full response. Well, the only one that took Zoloft and a full response is that value right there. Well, if we've got that, if we're trying to find a value over the total, right, that's a joint distribution. So they want to know the joint distribution based on who took Zoloft and got a full response. So you're simply taking 27 over 338. And that should come out to equal 0.08. In essence, that is simply just 8%. So again, definitely look at these and understand that this is these setups here on your actual big ideas, right? Your marginal distributions, which is the outside total over the overall total. Your joint distribution is looking at an inside value over the total. And your conditional distribution is looking at inside total over that rows total, okay? So, those definitely get those looked at and kind of ingrained in your brain a little bit, because those are commonly asked questions as well when they're looking at these for test questions, okay? All right, guys, well, that's it for this lesson, and we'll see you next time.